All right, so here we are, problem number 10, and it says in this problem we are drawing 5 cards out of the deck without replacement, and what is the expected value or expected number of reds in the deck, or in the hand, expected number of reds you get when you draw your 5 cards. And you're close here. You're close here. What you're neglecting is the idea of pulling out 5 cards. Like, so when I'm looking right here at your first value here, I'm not quite sure what's going on. The probability is 0 out of 26 out of 52. I'm not quite sure what's going on here. So I'm going to go ahead and revert back to just the whole idea of expected value, which is it's the value times the probability of that thing occurring. So what we'll do is whenever we do expected value, make a probability distribution table. So our value times the probability of said value, and the different numbers. So in this case, the value would be the number of reds. So we could either get 0 red, 1 red, and maybe this is what you're showing above. I'll just make sure I go through it so you can see it all. I don't know if I left myself enough space, but we'll find out. Anyway, so here we go. Those are all my different values. 0 reds, 1 reds, 2 reds, 3 reds, 4 reds, 5 reds. If I'm dealt 5 cards, those are my possible outcomes. Now what we need to do is calculate the probability of each of those outcomes. So when I do these problems, I always talk about rigging the game. So when I do these in class, I talk about rigging the game. So in this case, we're going to guarantee we get 0 reds. So out of the 26 reds, we're going to choose none of them. And then out of the 26 blacks, we're going to choose 5 of those. And the probability is always, and then these things would be multiplying because those things go together to make one set of cards. So therefore, that's the number of desirable outcomes where we have 0 reds and 5 blacks. And then the probability of that occurring is, well, there are 52 cards in the deck and we'd be dealt 5 of them. So rinse and repeat. Now we do it again for, all right, now the probability of getting exactly 1 red. Well, in that case, getting 1 red, that'd be 26 choose 1. Now we're going to have 1 red there, but then we need to have 4 blacks. So out of the 26 blacks, we need 4 of those. And again, there's still 52 cards in the deck, and we're going to choose 5 of those. And let's keep going with that. So that's 26 choose 1. Sorry, not choose 1, choose 2. We're going to get 26 combinations 2, because out of the 26 red cards, we want exactly 2 of the red ones. And then out of the 26 black cards, we want 3 of those. And then that's a total of 52. Choose 5. And if you haven't seen the pattern yet, I'll do one more. This would be 26 choose 3 for the reds. And then 26 choose 2 for the blacks. Out of a total of 52 choose 5. And so on and so forth. Okay. I'll leave those for you to fill in. So now, how we actually calculate the expected value is you take the expected value of our random variable is the value times its probability. So what is 26 choose 0 times 26 choose 5, or not choose, but combinations. And I get that in my calculator, my handy dandy calculator, being 65,780 over whatever 52 choose 5 would be. And you'll notice there's going to be a little bit of symmetry. You'd see it pop up in the 2 and the 3. Do you see that these are the same numerators? And you'll notice the same thing in the 4 and the 1, because here we're going to have 26 choose 4 reds, and then in the black we're going to have 26 choose 1. So notice that even though the order has changed, as we all know, order and multiplication does not matter. So therefore, there's a little bit of symmetry, so you can get through this problem a little faster. So you figure out what each of these numbers are, so you're going to do that. So now we're going to do 26 times whatever 26 choose 4 is, fill that in, over 52 choose 5, so on and so forth. And that will get you your answer. Now, this answer is really going to make you mad, because if you just stop and think about it, you say, okay, half the deck is red. So therefore, I expect half of my 5 cards to be red. So therefore, the answer should be 2.5. And this math, doing all this, will verify that. Okay, I hope that helps. Best of luck.